We can now continue with the most important part of material jetting processes. And if you remember, we said that we need to start with a liquid form, liquid state of the material, and then try to make it solid as this process is going on. And we have some different, let's say, methods for that purpose. The first one is hot melt deposition, and this one is very simple and the earliest methods. What we do, we simply heat the material until its viscosity actually is low enough to generate drops. And this was actually utilized by some initial commercial applications like Thermojet and Solscape T66. And we have seen their examples, but right now they are not utilized anymore. Instead, as we mentioned, binder jetting is more popular these days. And they try to do it for metals, ceramics, but as we discussed that for metals it's quite difficult. For ceramics, yes, it's doable quite, but you need to do many post-processing operations. And depending on the type of material you are using, you may have some extra requirements. You need to make some experiments, adjust your parameters so that it will be a proper material jetting process and using hot melt deposition method as the material modification approach. Instead of this hot melt deposition, we may also have solution dispersion based deposition. We actually discussed this one while we were discussing alumina and wax materials. And this way, in this approach, what we are doing, we are delivering the solids or some high molecular weight materials, polymers, in a carrier liquids. And this obviously carrier liquids will have low viscosity, and then once you may have some extra heat around and try to change their properties. And this way, we may easily produce some parts having different materials. But the thing is that you need to do again some post-processing. You can use this method for very small products, but for macro structures, it's quite difficult. You cannot have larger prints. And if you want to have in the macro structure case, we need to have some low concentration of the polymer in the solid. Another issue is that the controlling of this deposition pattern is quite difficult, since the motion of the liquid will be affecting your resolutions, your qualities a lot. You need to spend more time, spend more money on the machines actually producing larger products with this technique. And the other approach for material modification is the pre-polymer deposition. And this is the most popular way. Actually, object type of printers are using this method in their commercial systems. What they are doing is that they are jetting monomers and initiators at the same time. And since they have UV light beside their heads, they do the curing while these materials are actually hitting the previous layer or the substrate. And obviously, we don't need to heat them to very high temperatures. As you know, polymerization can happen at very low temperatures. The most important thing in the polymerization is the light you are applying. And for the accuracy, you need to be controlling this polymerization reaction. Otherwise, some of your parts, some of your regions may not be polymerized, and you will have less dimensional accuracy. Even with this type of printers, you can have some colored products you see. You may directly print your finite elements analysis results. Any questions, guys, about material jetting? We are done mostly with material jetting. In the remaining slides, I will be discussing binder jetting. But Yusuf, you may
Hocam,
your question.
What is the software challenges during the completion of the additive manufacturing side? When we transfer the file to CAM software, we need to use AMF, or we need to use another applications, proper applications in the CAM software.
We don't have any actually specific requirement for these processes. The fundamentals are the same pipeline is followed. You obtain the STL file or different file formats, import into their CAM software, do a little setting, and then print. And since we cannot again have internal structures in this material jetting or binder jetting, again, we need to fill the slices completely by having various scanning patterns, but the rest is the same with, let's say, SLS or SLA.
Colors, different types of materials need to be specified in the CAM software, right?
Yep, if you have different colors, different materials, if your print is capable of that, you need to do it in the CAM software.
Okay, thank you.
You're welcome. Any questions, guys, anymore about material jetting? Otherwise, we may start binder jetting. Actually, we know the fundamentals, but let's spend some time on it. Kaan, are you going to ask?
Hocam material jetting'de sadece tek nozzle mu oluyor her zaman? Yani onda da yine farklı materyaller ya da renk vesaire kullanımı olabiliyor mu? Yani nasıl yapıyor?
Yes, we may have, especially in the object type of printers, you may have many nozzles, even thousands of nozzles can be used at the same time, and they will be jetting such polymers and initiators as possible.
Object binder değil miydi hocam? Ben öyle hatırlıyordum da geçen dersten. Yanlış.
Material jetting, they are jetting materials.
Tamam.
So now let's focus on binder jetting. As we discussed, this was a patent by MIT, and they had given licenses to different companies, and all these companies focused on different types of materials, but the fundamentals were the same. They have a kind of a powder bed, they spread their proper material, and then jet these binding edges on the table on the powder bed and try to join these part material together. And they have usually binding edges in terms of, let's say, spheres, droplets, having 80 micrometers, maybe even less than that. And in these hats, they have several nozzles together, and with the help of them, it can be a kind of a line-wise patterning or line-wise printing. And again, we will have, since it's a powder bed system, we will have some powders left in the machine after the product is complete. So what we are going to do, again, we can do some recycling and try to use the same powder once again in our new printing processes. But the thing is that since this is just jetting the binding agents, at the end of this printing process, you will have a kind of a green part. And that's why after this operation is done on the machine, done on the printer, you need to take your part and do some infiltration processes. I think you remember the infiltration process. We discussed it in Sense kind of printing machine. You need to put it in a special oven and some infiltrating material, and then this material will go into the openings and fill all these porous regions in your machine, in your part. And the machine is not complicated. It's very similar to selective laser sintering or other powder bed fusion systems. What we have the powder beds, and obviously we will be having some unused powders around. Our building platform is always going downwards after each layer, and we need to have kind of powder spreader. You will be distributing some powders here. You may be using a hopper or another, let's say, platform which is going up so that you will have extra powder here. Once you have it, then with your doctor blade or counter rotating roller, you may spread it on the table. And once you have a new and uniform layer of powder, then you can deposit these binding agents on the table. Once they are deposited, these powders will be joined together. So in summary, if you repeat these processes, you will obtain the desired part. But as you know, This will be not the final product. You need to do some infiltration. We have some questions in the jet area. Yes, you may have colorful binder jetting processes if you are jetting, let's say, some colorful pigments through your nozzles. It's fine. The powder bed will be composed of single color, but once you jet, let's say, colored binders, you may have a colorful product. And we can recycle the unused powders. So what do you mean? Since there is heater, can we recycle unused powders? Where is the heater? We don't have a heater here. The recycling rate is much higher in this process. In the SLS, it's a bit lower, but in this one, since we don't have any heater around, just the powders which have the binding agents around are fused together, but the others are not fused together or joined together. So the recycling rate is higher in binder jetting processes. Anyone? Yes.
Burada da support structure'a ihtiyacımız yok değil mi?
No, you don't need to use support structure, especially if you are using polymers. But there are some, again, metal binder jetting systems. Some users actually prefer to use support structures for the metals, again, for proper heat dissipation and for higher accuracies. But for the polymers, I can say that you don't need to use any support structures, and you can manufacture many of these parts on top of each other. For instance, if this is our bed, again, I may have another product here, another one here. So this is a very useful, especially for medium-sized production. This is an example of an binder jetting hat. You see we have thousands of nozzles, and they are jetting probably some special binding agents. And we have some commercial products available in the market, and they are all started with the patent of MIT. And we have, for instance, Z Corporation, or simply Z Corp company. They mainly use plaster powder, and their products are used especially for investment casting. And X1 company is a very popular one. They use the same technology for metal printing and also sand casting molds. If you remember the video we watched, I think the previous week, it was about sand casting. But let's watch this one. I think the same one. So if it's the same one, then we don't need to watch it. So it's the same one, so we don't need to watch it. But you can have a look at their metal version. The fundamentals are the same. You spread the metal powders, and then you will have some special agents. With the help of that agent, the binding agent, the metal powders will be joined. But later, you need to do some burning off. These binding agents will be burned off, and another infiltration will be performed. And that will be done with the second metal, like usually copper, since copper has a low melting point temperature than steel and other kind of metals. So it's mostly preferred as the infiltration material. So you see some type of machinery available in the market. 3D system is mainly responsible for polymers. They are working on polymers. And then we have X1 company. They work on ceramics, sand particles, even metals. And then lastly, we have some Voxeljet company that are working on this special polymer, PMMA, and inorganic sand. And you can see their costs, and obviously we need to have 3 zeros here. They are quite expensive, but after the patent is expired, their costs are actually decreased but I don't think still they're cheap enough. Just professional companies are purchasing such printers and printing some high quality products. And there's such a typo in the textbook. Probably they prepared in Excel and forget to change the content of these cells. And the commercial systems are using similar CAM software. They import such things into their CAM software, the STL models, and then simply fabricate them. The advantage is that since the product is fabricated in a powder bed, you can have such channels, especially the sand molds. You don't need to have support structures or any kind of, let's say, special cores. Instead of cores, you can have two parts fabricated and then join them together through these holes. And it's very useful for casting operations. Any questions, guys? Okay, let's continue with some advantages. What are the advantages of material jetting? First of all, if you compare it with material jetting, it's faster. Since fast jetting the binding edges is much easier, and you don't need to use laser if you compare with other processes like SLA or selective laser sintering or melting processes. You don't need to have any toxic material like in the case of SLA. And you may have different combinations of powder materials and additives. Since powders are actually spread on the table with a special equipment, special mechanism, it's totally actually different from the jetting system. And on the other side, with the help of jetting, you may jet different materials, different additives, chemicals. So you may have various combinations of material powder, main material, and the agent material, which is not possible actually in material jetting processes. We can only jet a single type of material. And you may have some slurries, some liquid material with higher solid loadings. This is also possible. A question?
Ben şey soracaktım hocam, bu material jetting'de birden fazla nozzle kullanmak mümkün mü farklı materyaller kullanmak için?
Yes, but I don't think there is such a research or commercial. And technically it's possible. Just the thing is that you have two heads probably, and you need to control the temperature of these heads properly. And another thing is that these two materials can be joined easily. They should be kind of similar materials. You cannot use completely different materials. But as far as I know, we don't have any commercial machine, commercial material jetting system using many, let's say, nozzles at the same time. They are mostly using single nozzle. And for the binder jetting, we may produce ceramic parts, metal parts. They are produced in a higher quality compared to material jetting, since we are not heating the nozzle to very high temperatures. Just we are simply jetting the binder material. We can easily have color printing, and it can be done with jetting colorful agents on the table. But the thing is that the accuracies are quite lower compared to material jetting, since what we do, we join these main powders with the help of the agents, and once you burn off the agents, you'll have porous regions and you'll have more grainy surfaces. So it's a bit lower compared to material jetting. And obviously we know that secondary processes required. Once you do infiltration, again, you'll not be controlling the surface qualities easily. If it's important for you, then you need to do some extra, let's say, machining processes. Any questions, guys? Now I will show you a bit different process, somehow similar to jetting processes. It's from HP. and this is called as multi-jet fusion process. And now in this slide, we will simply compare this process together. Now I will switch to this website first. Okay, this is a very kind of novel process from HP, multi-jet fusion process. And here we are comparing it with the selective laser sintering process. Make sure that you go through this website after this lecture, but I will simply discuss the fundamentals. Basically, it's again a powder bed fusion system. It's again using a powder bed, but not a laser, and somehow similar to binder jetting technologies. So we can say that it's a combination of selective laser sintering and binder jetting process. This is an example of an SLS system, and in the multi-jet fusion systems, we have a carriage inject nozzle. Again, it's passing through the table, but this time is fusing actually the powders once this agent is deposited on the powder. So you don't need to do extra processes. With the help of this special agent, the powders are fused together. You don't need to have a secondary process. This is actually the main difference with respect to the binder jetting processes. So they have special chemicals, and this is a very useful one, and it's simplifying the whole process, and you can see the result is a very good one. And actually I have an example around. This is an example of the HP's technology, multi-jet fusion process. And as you see, since the part is produced in a powder bed, you can have such assemblies. And another advantage is that if you have a large building volume, you can produce, for instance, thousands of this same product. And in SLS, obviously, we have a point-by-point process since we have a laser, but in HP's technology, they have multiple thousands of nozzles, so we can consider them as a line-wise printing. And as you see, about 50% of the powder is recycled in SLS, but in multi-jet fusion system, about 85% can be recycled and reused. So here we have a nice comparison. The accuracies are quite the same. The building volume depends on the type of machine you are using. The layer thicknesses are quite low in the multi-jet fusion, and the minimum wall thickness is a bit lower. The minimum detail features are again better compared to the selective laser sintering. And the appearance are quite the same. We have a kind of a grainy surface. You cannot clearly see the layers. I'm not sure you can see or not, but it's quite difficult to see the layers in all these processes. But you can see a grainy finish on the surfaces. And in terms of the material properties, they're almost the same. If they use the same polyamide powders. And the thing is that in the material jet, multi-jet fusion system, they have huge amount of shrinkage, about I think 20%, but the HP company is aware of obviously this issue, and they try to adjust these things inside their CAM software, and once the part is produced, they will have the desired shapes. And if you look at here, if you are producing the same part for more than 100 times, then you will have a bit advantage in the multi-jet fusion process. It's more costly if you are doing selective laser sintering process. Any questions, guys, about this comparison between multi-jet fusion and selective laser sintering? So in summary, they are producing very functional parts, assemblies. Their accuracies are quite good. They have a kind of a grainy surface, but it's fine, it's acceptable. And their mechanical properties are quite the same. And the thing is that MJF is quite better in terms of, let's say, lead time or cost, since you can have you can recycle many of the powder. Most of the powder is recycled, but on the other hand, in SLS system, since we have laser and heater around, some of the powders may be unused powders may be joined together. So that's why in terms of cost, we can say that multi-jet fusion is a bit better and faster. So this is actually end of material and binder jetting processes. Any questions, guys, do you have?
Hocam ben şeyi sorabilir miyim? Bu multi-jet fusion sisteminin binder jetting ile farkını ben çok net anlayamadım da. Tek farkı bu high power infrared energy source geçmesi olması.
They are all actually jetting the binder, but the thing is that multi-jet fusion has a special binding agent. It's actually fusing the powders. In the conventional binder jet, you kind of join them together, but do not fuse them. The powders are not fused. But in the multi-jet fusion, your agent actually helps these powders fuse together. So you don't need to have a secondary process. But in the binder jet, once you get your product out of the printer, you need to do further sintering, sometimes further infiltration processes. In multi-jet fusion, you simply take your part and use it. This is the main difference. And this difference actually is resulted just due to the chemistry inside the agents, the binding agents. Any questions, guys? Yep.
Multi-jet fusion'la alakalı bilgimizin az olması SLS'e göre aynı zamanda SLS kadar yaygın olmamasından mı ileriye geliyor?
No, actually, since it's a completely different system, that's why we didn't focus more on it, and we don't have a chapter inside our textbook. That's why I didn't cover it much, but these days it's getting popularity. So that's why I put it here. You should be aware of this technology. It has similarities with binder jetting, and on the other hand, it has similarities with other powder bed fusion systems.
Teşekkürler hocam.
Welcome. Another thing, it's only used by HP. This is HP's special patent. Other companies cannot use it. So that's why we are only discussing it for just 5 or 10 minutes.